Long before cities, our ancestors lay under a vast, dark sky. They saw the same stars we see. The sun brought warmth and light, dictating their lives. The moon marked the passage of time, its phases a celestial clock. Early humans were keen observers, their survival depending on understanding the patterns above. This was humanity's first astronomy, born from necessity and wonder. Constellations were characters in epic stories, gods and goddesses, heroes and monsters. These celestial narratives explained the unexplainable and preserved cultural memory. The sky was their storybook, calendar and map. The rising and setting of specific stars heralded the changing seasons. This knowledge was crucial for agriculture and seafaring. Monuments like Stonehenge stand as testaments to their understanding of solar and lunar cycles. These were not primitive people. They were scientists in their own right. Their view of the cosmos was often geocentric, Earth at the center. The heavens appeared to revolve around them. This perspective, while incorrect, was a logical interpretation of the available evidence. As civilizations blossomed, so did the study of the heavens. The Babylonians meticulously documented celestial movements. They developed techniques to predict events like lunar eclipses. Their star catalogues laid a foundation for future astronomers. The ancient Greeks expanded upon this knowledge. Aristotle proposed a geocentric model, while Aristarchus suggested a heliocentric one. Eratosthenes calculated Earth's circumference with astonishing accuracy. The Mayans developed an accurate calendar system and built observatories. They predicted solar and lunar eclipses with profound accuracy. These early civilizations shared a common drive to make sense of the cosmos. They established the idea that the universe was knowable. Their legacy is the enduring spirit of exploration they ignited. The Renaissance brought a new wave of discovery. Galileo pointed the telescope towards the heavens. He observed mountains on the moon and Jupiter's moons. His observations supported the heliocentric model. Isaac Newton formulated laws of motion and universal gravitation. The cosmos was governed by universal laws understandable through mathematics. Rockets, once used for fireworks, became vehicles for space travel. Konstantin Tsiolkovsky developed the principles of rocketry. Robert Goddard launched the first liquid-fueled rocket. Hermann Oberth inspired a generation of engineers. These pioneers laid the groundwork for the space age. They believed humanity was not forever bound to Earth. Their work transformed science fiction dreams into engineering challenges. The dream of reaching for the stars began to take shape. The Cold War rivalry became the crucible for the space race. The launch of Sputnik 1 by the Soviet Union shocked the world. It demonstrated Soviet technological prowess. The United States responded and the space race was on. The Soviets achieved early successes with Sputnik 2 and Yuri Gagarin. The United States established NASA and launched the Mercury program. Alan Shepard and John Glenn became American space pioneers. The space race was marked by rapid innovation and intense pressure. It inspired a generation to look up at the stars with new hope. President John F. Kennedy declared a national goal landing a man on the moon. The Apollo program was born, requiring immense complexity and cost. The journey to the moon was fraught with challenges. The Saturn V rocket had to be designed and tested. Spacecraft capable of traveling to the moon needed to be engineered. Astronauts had to be trained for complex missions. The Apollo 1 fire was a grim reminder of the perils involved. On July 20th, 1969, the Apollo 11 lunar module descended towards the moon. Neil Armstrong and Buzz Aldrin were aboard. Armstrong announced, "Houston Tranquility Base here, the Eagle has landed." Armstrong stepped onto the lunar surface, uttering, "That's one small step for a man, one giant leap for mankind." The moon landing was a defining moment of the 20th century. 6 Apollo missions successfully landed humans on the moon. The achievement transcended national boundaries, becoming a symbol of human collaboration. After the moon landings, the focus shifted to space stations. The Soviet Union launched the first space station, Salyut 1. The United States followed with Skylab. The Soviets continued with the Mir space station. NASA developed the Space Shuttle for versatile space access. The Challenger and Columbia disasters highlighted the risks of spaceflight. The International Space Station, ISS, was a collaborative effort. The ISS serves as a unique microgravity laboratory. Astronauts from many countries have lived and worked aboard the ISS. Robotic missions have been the workhorses of solar system exploration. Probes were sent to our nearest planetary neighbors. The Soviet Venera program landed on Venus. NASA's Mariner missions provided close-up glimpses of Mars, Venus, and Mercury. The Voyager missions revolutionized our understanding of the outer planets. Mars has been a prime target for robotic exploration. Other missions like Galileo and Cassini-Huygens expanded our cosmic horizons. These robotic explorers constantly send back data that rewrites textbooks. The 21st century witnessed a shift to commercial spaceflight. The Ansari X Prize demonstrated private companies could develop reusable spacecraft. SpaceX and Blue Origin emerged with ambitious goals. SpaceX pioneered reusable rocket technology. Blue Origin developed the New Shepard system for space tourism. A diverse ecosystem of commercial space companies is emerging. The rise of private spaceflight is transforming the landscape of space exploration. Humanity is poised to return to the Moon with the Artemis program. The Moon will serve as a proving ground for Mars missions. Both government agencies and private companies are developing technologies for Mars. Robotic missions and space telescopes will continue to explore the universe. The James Webb Space Telescope is revolutionizing astrophysics. The prospect of asteroid mining holds potential for future exploration. The journey from ancient stargazers to interplanetary missions is a testament to human curiosity. The future of space exploration is about expanding human presence and ensuring our long-term survival.